Okay, now let's call out the third presenter. Let's welcome with a big round of applause for Electromagnetic Pollution, a Hidden Challenge and a Smart Solution by Hassan.
네, 참가자 3번 핫산입니다. 준비를 참 많이 한 것 같습니다. 네, 얼핏 보기에는 뭘 구매해야 될 것 같기도 하고 약간 좀 느낌이 그렇습니다. 네. 오케이, ready?
Let's start.
오케이. 자, 시작하겠습니다.
Hello everyone. Let's start with the question. What comes to your mind when I say pollution? Anyone? That's right. We always think of smoke from industries or plastic in the sea or garbage on the stage. But what if I tell you there is another kind of pollution? One you can't see or smell, but comes from something you love to use daily. Your cell phone. That's right, it's called electromagnetic pollution. Any electronic device that uses electrical energy produces electromagnetic waves that are not only harmful to other sensitive electronics, but also to the surrounding environment and the human beings. So, just like you wear masks to protect yourself from air pollution, you need shielding materials to shield us from electromagnetic pollution. The primary function of a shielding material is either reflect or absorb electromagnetic radiations by interacting with charged particles like electrons. So the main property of a shielding material is conductivity. You must think metals, being the most famous conductors, should be best fit for this application, right? That's true, but not always, due to the rigid structure of metals. Imagine wearing this to shield yourself in the future. Not a good idea, I think. So, we need flexible materials. And here comes the superheroes, just like these two, the super materials of material science, graphene and MXene. These are the game changers. How do we use them? It's as simple as you can think. Follow me. You have got your graphene, MXene. Take any stable solvent. There are stable solvents which you must know, which are not harmful. You can even drink as well. No, not that safe. And make a solution of these two in this solvent. Take any air sprayer and replace the paint with this solution. Now take any flexible substrate. Flexible like a cloth or any flexible substrate like PET. Spray coat it, and here you go. You made yourself a flexible, conductive and lightweight film that is capable of blocking more than 99.99% of EMI shielding. Thank you so much.
네, 잘 들었습니다. 세 번째 참가자 핫산의 발표 잘 들었습니다. 네, 뿌릴 줄 알았는데 뿌리진 않네요. 네, 자, 네, 질문 부탁드리겠습니다.
I'll go start. 진짜 뭘 사야 될 것 같이 발표를 잘 하셨는데 I feel like you did so well. I feel like I need to buy. Oh, go ahead.
Sorry, sir.
Yeah.
Give me a...
So I have a couple of questions. When you said that flexible structures and you talked about those film, but the material-wise, they're not actually flexible. They're rigid, but they're thin. So when you talk about flexible, you're talking about rigid material making it thin, or actually flexible materials incorporating into your shielding system?
Actually flexible. Like, for example, any material you take, for example, let's say metals, you cannot adjust their structure. You can make as thin as possible. But if you go below certain thickness, their stability is an issue. For example, if you go below maybe 0.1 micron, then you cannot make a stable film. But if you just make a film with these materials, you have to just spray coat it. For example, if you want to make your clothes shielding material, then you can just spray coat it with graphene and MXene. And if you are good enough to spray coat it with stable or evenly, then you can, of course, you can get your.
Another small question. You talk about two methods, reflection and absorption. Which one is better? Which one is better or worse, or pros and cons?
Mostly used is reflection one. It reflects most of the rays are reflected by materials. Like if you make smooth surface, the reflection is increased. But nowadays, due to after invention of MXene, MXene is a layered structure. So the absorption increases because total internal reflection is a phenomenon in science which if there are two layers equally distanced, then electromagnetic ray can stay within a material without going out. So it's nowadays they are working on absorption as well.
Thank you for your talk. I have two questions. Just the first question is about how effective your new material will be. So what will be the prevention rate that you expect?
Right now, if we use only MXene, it's as good as a metal. You can go up to as equal as a metal shielding like copper or any other material which you can think. But the issue is MXene is not stable. That's why we have to add graphene to it. And now it is decreasing. So if you can make a high quality graphene and add it to MXene to stabilize it, then you can go up to maybe 90 decibels, which is 99.109. So you can use in any application.
That's really great.
Yes.
The second question is about, can we expect to use your new material in everyday life, like clothes,
Yeah,
as a fashion item?
that's our main aim. Like when we write some research, our first paragraph is about this, for daily life uses. Right now, 10% of our daily usage, things like cell phone, laptop, are electronic, right? In the future, everything will be almost electronic. Maybe these chairs are robotics. Everything will be produced in electromagnetic, so we cannot ignore it. So we need some shielding, right? So why not dyes, painting just your clothes with this material?
Like superhero?
Thank you.
Thank you.
Actually, because we are surrounded by electronics, I was considering what was your primary, product of concern for your material, for your development.
Maxine,
I'm sorry.
sorry,
my English.
I didn't get
Yeah,
your
yeah,
question.
yeah. My English was poor. Because we are surrounded by electronics. I don't think we can cover all of those materials, all of those products with your material.
Yes,
Yeah. So, what is your primary target?
primary target it's called terahertz shielding. Any device that produces waves which are in tera means about 10 to power 10 or 12. So very high frequency. So if it is producing very high frequency waves, so you can protect that with these ones, not small ones. So I didn't include it because it was too field specific to explain waves about this. But if it's very dangerous, then you can block with this one.
For example,
For example, some robots, they produce very high or very, for example, if you want to protect your hospital equipment, like ECG, like pacemakers, you need a shielding material. So because these are very sensitive electronics, for these you can use right now, for these, to protect these devices. Is it
I
clear?
found, it's very clear. And I have another question
Yes.
because it has interesting features like flexible and also conductive. So, can you think of any other usage for this material?
Yes, this is one of the most researched material right now, MXene. So, like, some people are focusing on conductive inks. for flexible electronics. Like you don't need to use wires. Just you can paint it with the ink and you can make conductive.
Yeah.
So many application I can think of right now. So that's why super materials.
Thank you. I enjoyed your talk.
Thank you so much.
네, 그럼 이제 질문은 다 되신 걸까요? 네, 고맙습니다.
Thank
Hassan, thank you for your presentation. 네, 고맙습니다. 자, 이렇게 해서 세 번째 발표자까지 함께 만나봤습니다. 자, 이제 3명의 참가자를 남겨놓고 있고요. 여러분 마음속에도 청중 인기상을 위한 마음에 나만의 인기상의 주인공 꼭 마음속에 간직해 두시기 바라겠습니다. 자, 세 번째 질문 우리 핫산에게 질문 드리도록 하겠습니다.
Okay, Hassan. Especially on wearable devices, is there any disadvantages like decreasing efficiencies if you apply your suggested material?
Mostly my talk was about applying shielding materials to affect the devices that got affected. For example, if something is producing electromagnetic waves, you should apply shielding to the device which is under effect. For example, as I say, ECG. So if there are many devices around, you have to apply the shielding to that device. So if you are wearing, for example, any other device, then it's already in contact with your skin. So it will be very difficult to apply shielding to yourself while wearing any electronic device. But mostly electronic device like which you say, it's not right now. It's not that damaging, you can say. So there is no such harmful effect which is proven right now for very small electronics. But for when you increase the sensitivities or something like that, for example, if you go on decreasing the channel length for transistors, then there is a problem. But right now, if you go for wearable devices, there is no problem. So no need to worry about this thing right now.
네, 질문에 대한 답이 되셨는지 모르겠습니다. 우리 민우홍님 어디 계시죠? 민우홍님, 네, 제가 전달 좀 해주세요, 핫산. 네, 한국말 잘하네요. 네, 고맙습니다. 대상의 주인공입니다. 제 10회 내 연구를 소개합니다. 가장 발표를 잘 해주고 이해 쉽게 잘 이야기해 주신 분이십니다. Congratulations, Hassan! 네, 축하드립니다. 대상의 주인공이 됐고요. 상장의 내용은 전과 동일합니다. 사진 함께 찍도록 하겠습니다. 정면 바라봐 주시고요. 네, 고맙습니다. 하산 축하드리고요. 우리 박사님께도 감사의 말씀 전해드립니다.